In this video, you're going to learn how to sketch a rational function. In previous videos, we learned how to identify horizontal asymptotes, we learned how to identify vertical asymptotes, and to identify holes. Here we're going to put all of those pieces together. So let's start off. We're given a rational function, and the first thing that we always need to do is we need to factor. So I'm going to factor the numerator and the denominator. The numerator is a difference of two squares. The denominator is a trinomial. So I have this factored. Now I'm going to identify the holes. You don't have to identify all the characteristics in this order. Okay, that's just the order that I prefer. So we can see here that we have a common factor in the numerator and the denominator. So that indicates that there's going to be a hole at x is 3. Now I'm going to, remember that is just our x coordinate of the hole. I'm going to take that 3, I'm going to substitute it into the remaining factors. That's x plus 3 over x plus 1. So I'm going to substitute that everywhere I see an x. So that's 3 plus 3 over 3 plus 1. So we get 6/4, and I'm going to simplify that. So that's 3/2. So we have a hole at the point 3 comma 3/2. And I'm just going to turn that into a mixed number because I'm going to graph this. So remember, that's 3 comma 1.5. So on my graph, I'm going to find 3 comma 1.5, and I'm going to put an open point. Okay, that's a hole. So that, remember that. The graph is going to pass through there, but it's not going to include that point. Okay, vertical asymptote. I'm looking at the denominator. I'm looking for any factors that are left in the denominator. So we have x plus 1. Now remember, factors in the denominator cannot be equal to 0 because if they are, then our denominator would equal 0, and that would be undefined. So I'm just going to solve this, and I find that x cannot equal -1. I should put a slash to the equal sign. So x cannot equal -1. So on my graph, I'm going to put a vertical asymptote going through -1. X is -1. Okay, the next step I'm going to do is identify either horizontal asymptotes or slant asymptotes. So if I'm looking at this rational function, I'm looking at the highest degree in the numerator and the highest degree in the denominator, and we can see that we have an x squared in both the numerator and the denominator, and their coefficients are both 1. So if the degrees are the same, then there's a horizontal asymptote at the ratio of their coefficients, which in this case is 1 over 1, which is just 1. So that means we have a horizontal asymptote at y equals 1. So I'm going to put a dotted line indicating that that's a horizontal asymptote on my graph. Okay, the next characteristic is my y-intercept. So the y-intercept, we know the x-coordinate is 0. So I'm going to substitute 0 into my function. Okay, so that's essentially what I'm doing. I could do the math. Remember, these zeros are really just canceling a lot of things out. So I'm going to be left with -9 over -3, which is 3. So my y-intercept is at 0, 3. So back to my graph, I'm going to put a solid point at 0, 3. My next characteristic is x-intercept. So x-intercepts occur when the y-coordinate is 0. So that essentially means when this function is equal to 0, and that's going to occur when the numerator is 0. So my numerator, the only factor I'm left in the numerator with is x plus 3. So x plus 3, when x plus 3 is equal to 0, I will get my x-intercept, so I'm just going to solve that. So when x is -3, my numerator will be equal to 0, so the value of the entire function will equal 0. So I have an x-intercept at negative 3 comma 0. So that's going to be right here. Now, based on what we know of rational functions, you can see that we have a point and a hole in the top right of, like the top right, we could almost think of it as like a quadrant where the vertical and the horizontal asymptote intersect. So I know that my graph is going to ride along that vertical asymptote, and we could see that it's going to be decreasing. It's going to pass through the hole but not include it, and it's going to ride along the horizontal asymptote. Now, I suspect that in the bottom left, that my graph is going to look something like this, and it's going to ride along the horizontal asymptote on the top and the vertical asymptote towards the bottom. But let's just make sure that that's true. I'm going to find one other point. I'm going to look for the point when x is negative 2. So let's plug negative 2 into this function and see what we get. So we are going to, so we get negative 2 squared minus 9, and then negative 2 squared minus 2 times negative 2 minus 3. So if we do the math here, we get negative 5 in the numerator, and we get 5 in the denominator. So we get the point, negative 2, negative 1. So if we graph negative 2, negative 1, yep, you could see right where this falls. Okay, so that indicates that my original graph that I drew is correct. And here we have our graph of a rational function, including holes, vertical asymptotes, horizontal asymptotes, the y-intercept, the x-intercept, and an additional point to check our intuition.